Yeah, so I was just going through one of the EDA notebooks here before the meeting started. I could just share that a sec. Yeah, as I say, I'm not sure exactly which competition we're choosing to do, like on the survey. Yeah, so at the survey, it's 12 people for the rainforest one and 6 for the pets at the minute. So it looks like the rainforest one has sort of is winning, but I'm not sure like when Srinivas is going to call a halt on it. But yeah, so I've just been looking at this one, the rainforest one, and yeah, within the code section, there's a couple of like EDA notebooks which are quite good. So the one I'd been looking at was this one, which makes things like pretty simple. So like basically with the rainforest competition, you get given a couple of CSV files which describe, well, if I start at the beginning, sorry. Yes, like basically you get given like a load of audio files, and like in the audio files, there's 24 different species of bird or frog, the audio sounds of them, and like each audio clip may contain like one or more of those animals within it. And you've just got to classify to say which animals exist in the audio clip. So like on the submission file, for each of the recordings, you've just got to say what the probability of each animal is. So like each clip would probably contain like sort of between sort of 1 to 4 different animals. And there's like 24, I think, different species. So like in most cases, all of these would be set to 0 or close to 0 for your probability, saying like those animals don't exist. And then for the animals that you do think exist, you would set those probabilities as close to 1 as possible. Yeah, so like this here is like one of the sample notebooks, and like shows like a sort of pretty easy way to tackle the problem. So here you get given the data describing which animals are in which clips, and in the training data as well, it tells you like at what time in the waveform that animal is present. So for each of the like entries, for each row in the CSV file, you get like one of these audio files. So like here you can see like in the audio file, you got like spikes at different times. So for example, this is probably some bird or something making a noise at this time. And so like the row that matches this in the CSV file will have an entry telling you what species, and it'll give you like the time, the start time and the end time, saying when that's present. So this is one way to deal with it, where you take like the actual audio wave file and like chop off bits of it, so you just get the bits that are of interest to you, and then you convert from a wave file into a spectrogram file, which basically like shows the frequencies as an image. So like once you've converted from like audio to an image, then you can just like use image processing networks. So you can just use CNNs to tackle the problem.
So here, you on Y you have frequency, and then the color is intensity, right? Basically the strength of signal.
I think so, yeah. So like, yeah, I'll go down a wee bit in a second. He says exactly how we get this. But yeah, so like basically he's converted the problem from like an audio problem into a visual problem. Yeah, so I'll come back to the spectrogram thing. I don't understand it fully myself, but yeah, so there's like loads and loads of like just helper functions here for dealing with the problem. Yeah, so I'll come back to the spectrogram thing in a second, but in the CSV files that you get given, you get like given two two files. Sorry, finding it hard. Oh yeah, so you get given like a training underscore TP CSV file. So like each row of this is like the recording ID, which links to like the wave file. And then this is the species ID. And like this is the time that it occurs at the Tmin and the Tmax. Like that's the period in the waveform when like this species can be heard. And then for different species, they can have like different song types. So one species can have a couple of different songs that can be detected, but you don't need to put that in your submission file. You just need to put what species is in. And the other thing is each recording can have like multiple species. So if there was multiple species in this recording, then this entry here, this recording ID, would appear on several rows with a couple of different species IDs. Yeah, so like we can see like for like this recording ID, species number 17 exists between whatever that is, 50 seconds and 56 seconds. And then the second file that they give you is like a training false positive file. So what it's actually been generated from is supposedly like they had some model themselves where like they analyzed all of the CSV wave files, and like then their model came back saying, okay, in this recording here, recording blah blah blah, they found species ID 21 at this period in time, but then they gave that file to like a human expert who said, no, that's not that species. And so like all in the false positive file here, this is like saying that at this time in the waveform, species 21 isn't present. So I'm not entirely sure how you go about using them, but you can see here, so like this, in this file here, there's three different sort of periods in the waveform that these three species definitely don't exist. And yeah, so up here I'd taken this waveform, and so it's got like one definite species that does exist, but it's also got like three parts of it where there's three species where noises will exist, and it's definitely not these three at these times. Yeah, so back in this guy's one, yeah, like after all these hundreds of helper functions. Yeah, so here for each of the waveforms, so like the waveform is just like a 1D thing where it's basically just like the magnitude, like at any time in the waveform. And then he uses the short time Fourier transform to get from the audio to produce the spectrograms. So like it's producing the frequency things. I'm not familiar with this, but he says something about like it effectively sort of uses time windows. So it slices up like the waveform into times and then looks at the frequencies that exist in each of those times. And like by doing that and by sort of cutting off the ends, he can end up like with images which have slices. And so like you can have like sort of regular sized images to stick into a CNN. Yeah, so like if you run this code, I'm not sure, is it run here? Oh yeah. Yeah, so like here's the waveforms. So like each of these waveforms, like that's the name of the file and the species that exists. And then he's used like the Fourier transforms, which is now converted, like there's the waveform and it's converted it into these spectrograms. And like each of those comes in with a sound as well, but I don't know if you can hear those playing through my system, probably not. But yeah, so like this one doesn't look like it's got sort of any animals, maybe one little one at this point. Whereas like this one here, you can see there's like lots of peaks. So there's probably like several places on here. Yeah, so like after he's done that, all of the waveform files, all of the audio have been converted into these rectangular spectrograms. And then in his model, basically he just uses like a CNN efficient net, sticks these in, and then has like a softmax classification layer for like the 24 classes, and like trains it, and that's it. Obviously, like this is just like a very simple sort of EDA model just to get people up and running, and a lot of people use a lot more advanced sort of approaches to the problem. And like I think people actually sort of deal with the audio and like use LSTMs and stuff and RNNs on it. But like this is like one way to get up and running. I'm not sure what else is in the rest of this. Yeah, so it's just analysis of like the results he gets. Then because of the fact that like it's like a multi-label problem, so like for each image or for each waveform, sorry, there's multiple possible species that can exist. It uses like this funny label weighted label ranking average precision metric, which is a bit strange. Yeah, so I didn't understand this, and like going to like the what's this, the help page here, that didn't really help much either when I went here. So there was a good post somewhere about, yeah, not sure how to. I don't know how I can get to the chat, but yeah, I'll post a link to like, basically all it does is for each of your predictions, it ranks them like according to the probability that you give. So like in this Stack Overflow post, it sort of like really simplifies the problem and shows you like if you've got like dog, cat, and bird or whatever. So you have like this type of array. So like the ground truth would be like this. So like in this case here, this is like saying like a cat exists in the example, but like dog and bird don't. So like then if you put that through your model and you got this prediction, so you've got like a 0.9 prediction that it is a cat, and then 0.2 for dog and bird. So because of the fact that your highest prediction here was matching with the ground truth, then in that case, you would end up like with a score of 1, which is the highest you can get. Whereas if you'd had these swapped around and then you'd instead predicted like dog as the highest, you'd end up, depending on what score you give to cat, you'd end up like with a lower one. So like this post here sort of fully explains how it sort of works for the multi-label case. So in the actual competition here, like looking at like the winners of it, you can see like here, like this is in the private one. So like this is like the winning solution to the competition. So they're like 0.98, which is like practically perfect. Like as I say, the highest score you can get is like 1.0. So they're very close to that. Whereas like when I just put one of the test EDA ones in. So I started like, it's like 0.72 I was getting with that. So there's definitely some room for improvement. And yeah, so that's as far as I've got like with looking into this competition at the minute. But yeah, so Yuri, like the post that you'd put up about whatever the other sort of Kaggle club was, the guy's solution there like was very useful. So I haven't finished watching all of it, but now I understand sort of better what's going on. I'll go back to it again. Perhaps I'll understand exactly what he was like saying.
Yeah, I also found slides. I posted them on the same post.
Oh, was it the slides that he'd used, was it?
Yeah, yeah.
Oh, all right.
You want to read? Yeah.
Yeah, so I'd started watching his thing, but like I didn't completely understand, so I thought I'd go off myself and have a look and just like take a look at some of the simpler ones. But yeah, I'm now in a position to go back. But yeah, like it's like looks really useful. So Yeah, so that's as much as I've done this week. So I'm not sure if anybody else has had a chance to look at any other things.
No, I haven't. I just was able. I just ran pets just to see if it's running. That's it.
Right. Yeah, so I'd seen, Yuri, that you'd voted for the pet competition. Was it the one that you would have preferred to do?
I'm flexible. I just I don't know, just personally like that data more.
Yeah.
I
You just like pictures of cute pets?
no, I worked with signals a lot before, so
Right.
but not audio.
Yeah, so I'm not sure if anybody else has had a chance to look at anything or has anything to add. Yeah, for anybody joining in for the first time, normally like this group is run by a guy called Srinivas, but he's in the middle of like flying back to the US, so he's not about this weekend. So hopefully next weekend he'll be back and everything will resume normal service. Yeah, so as I was like saying at the start, like it looks from the poll as if the majority of people are interested in doing the competition there I just described, the rainforest competition. So if you can get a chance, just go along. If you just go into the competition on Kaggle and take a look at like at the data set, and take a look at like the notebooks. There's like quite a few. If you just look for the highest ranking notebooks, there's like quite a few which just sort of run through the problem and describe how you can handle audio files and like sort of show different approaches to tackle it. What we tend to do on here, we would like sort of pick a competition that has sort of recently finished, and then we would sort of tackle it sort of with our own ideas to start with, and just like sort of starting with the EDA notebooks, and see how far we can get with that, taking like the EDAs, the simple ones, and then adding our own ideas and seeing can we sort of improve upon those scores. And then as we go through, we would sort of like take a look at sort of papers and things that relate to the problem, and yeah, like sort of gradually improve our scores. And then just at the end, as we're sort of running out of ideas, then like a lot of the notebooks that have won the competition or have come close to the competition winners, they all are up there as well. Or like if they're not up there, it tends to be the teams that won like put a description of the approach they took. So like it's only sort of later on in the process that we would sort of go and take a look at those. We don't sort of go to the winning solution to start with, otherwise we wouldn't sort of learn anything on the way. And the other thing is, yeah, we choose competitions that have finished on Kaggle just because of Kaggle's rules. Basically, you're not allowed to sort of share code publicly on an actively running competition. So it means that like if we have like notebooks that we want to share with each other, we'd be breaking the Kaggle rules if we did an active competition. So by picking closed competitions, then it means we can discuss those freely.
Yeah, Steve, I have a couple of questions here. The species detection is like 20 times more data than the pets, right?
I'm not sure. I haven't really looked at the pets one. Yuri's looked at that, but yeah, I think with it being audio files, yeah, I think it might be quite large in the size of the files.
Yeah, I see it's about 20, a bit more than 20 times. So I wonder how much is the resources or processing requirements for the species detection?
Yeah, so like as I say, I've only run the EDA things, and a lot of the notebooks on here that I've seen are like our TPU based ones. And so in Kaggle, you get like, I think it's 20 hours a week free TPU. So, unlike the notebook I ran, it took about half an hour TPU time. So normally I would like sort of just try and stay on Kaggle because it avoids the problem of like having to like download any data off to Colab. Yeah, so it's like 57 gig, this data, which if you were to like take that over to Colab, it would probably like eat up your entire Google Drive. Yeah, so like I would tend to just try and keep on Kaggle if I can, and then just use whatever time is available there. So you get 40 hours a week GPU and 20 hours a week TPU. So like normally it should be enough, as long as you're not like sort of, that is one important thing. Like anytime, if you have like a notebook, once you've sort of are happy with the notebook and you've sort of finished editing it, when you click on like the Kaggle save button, then you need to remember to turn the power off on the one that you're editing as well. So is it it'll just like save in the background there, and it doesn't keep your edit running. Otherwise, it'll sort of take twice as much of your TPU time.
So can we say that we have we can be able to make one submission per day with no problem, right?
Oh yeah, I think you can make as normally like they have a limit of 5 submissions a day. I'm not sure like with the competition ended, does that change at all? But yeah. Normally there shouldn't be any problem on that.
Okay.
Okay, thank you.
Yeah, I've just. Can you see my screen again here?
Yes.
Yeah. So yeah, so like this here is like the notebook I was like just showing you before. So yeah, so like if I edit this, yeah. Oh, right. So you can see here like this, the TPU is turned on. So like this notebook's a TPU thing, and like in here it's using TensorFlow records, which are sort of set up for running on TPUs. And yeah, like if you use Keras, it's really easy to use the TPUs on them. Like this bit of code here just detects if you've got like the TPU on and sort of sets it up for you. And then down the bottom, when he actually comes to train the model, yes. So here, basically just using this with strategy scope, having the model with inside that with statement automatically puts it onto the TPU. So like if I'm running here, you can see like now the TPU is up and running. But when I hit save on here, so like when I hit save now, so you can see it's like started to save. At this point here, like the TPU is now running twice. It's like running once here within my notebook, and it's running for a second time here on the save. So like at the minute it would be using twice as much of my TPU time. So as soon as you've clicked on this, because of the fact that I chose like a full commit, it's going to run the entire notebook. And so the saved file will have like all the cell outputs. So as soon as you've started saving here, you can go back up to the power button and you can stop the session. So like that's the edit has stopped, but your saving is still running. And so like then once you've done that, then you're fine to like leave the notebook, and that's okay. Whereas like if you had left this one here running, you'll soon run out of TPU time. But yeah, so like as I say here, like it's like mine must have just reset. So I've got like 30 hours in the week on a TPU, and I think you've got 40 hours on a GPU. So overall, I think like there's like enough time just to keep the data on Kaggle and not have to worry about taking it off anywhere else. And so like if you are just playing about with this a couple hours a week, should be fine.
Okay, thank you, Steve.
The other thing is, like, I think any solution you do would use spectrograms, or almost everything, but spectrograms are much smaller than the audio files. And also, if you look at the pictures, like useful data is really takes much less time, right? Because there's basically nothing, and then something interesting. So one solution would be to create spectrograms and like save spectrograms outside of Kaggle. And then next step would be save spectrogram, but not the whole duration, but only interesting parts. But that's yeah, that's already kind of manipulating data a little bit. But just saving spectrograms should be enough to reduce the size significantly.
Yeah, plus as well, like when you do that, if you're just working on the spectrograms, then you've sort of got rid of the waveform to spectrogram translation time. And so, yeah, if you've saved the spectrograms, then your notebook should run faster because you don't have to do that the second time either. Yeah, so has anybody got any questions or anything to add?
So are we restricted in just TensorFlow since the data set is in TF records? Or can we just make them spectrograms and then use anything we want?
Yeah, I'm pretty sure you can use anything you want. I think it's just they've given those TensorFlow records if you want to use them, because I think what they contain, I think the TensorFlow record that's there sort of wraps together the information that's in the CSV file and the waveform. So that the two things are separate anyway. You can like go through and use the CSV file and the actual wave file, or you can just use the TensorFlow record if you're using TensorFlow.
Okay, got it.
Hi all, can you hear me?
Just about.
Okay. I have one doubt. Like, how will we use like there's two more files like train two positive.csv file and train false positive.csv file. How will we use it in the model? Like,
I'm sorry, I was having trouble hearing that.
okay. Can you hear me now?
Yep.
Okay. In the files, there are like train train underscore tp.csv and train underscore fp.csv. How will we use it in our model? Like there are, will we use it for like correcting after submission, just correcting using like if we train some model, then we'll get some predictions and some are wrong. How will we use a train false positive file in it?
Yeah, so like the true positive CSV file, it's obviously like the one that you would use sort of the most. It's the one that would give you like the your sort of your true labels or whatever if you're using a classifier. I'm not entirely sure how they use like the false positive file. Maybe just I don't know, maybe like if you've sort of trained your model to classify like each of the species, then you could like run a second stage against the false positive file to see if your thing is showing up the ones that they had as well. But I haven't got that far yet, so I'm not entirely sure how you're meant to use that. So I'm not sure, sorry, if that answered your question.
It's okay. Thanks.
Okay. Yeah, so like if nobody has any other questions, then it's probably best if we leave it here. And as I say, Srinivas will be back next week, and hopefully, yeah, like as Yuri said, hopefully he'll publish it like the proper link up and put it into like the general TWIML chat. Yeah, so hopefully next week a few more should join. So, but if you can like all sort of take a look and see if you can get anywhere with this, it'd be good. So if nobody's got any other questions, we'll just leave it there. Okay.
Okay.
Thanks.
Thank you.
Thank you,
Okay,
Steve.
cool. See you next week. Cheers. Bye.